In this clip, we're going to illustrate how to combine two attributes to get a better image of a reservoir. The analysis is done at well-log resolution and is going to be complemented later in another clip at seismic resolution using synthetic data. Let's start by doing a QC of the input data, plotting BP, BS, and density. This is the scatter plot with P wave velocity in the x-axis, S wave velocity in the y, and density as the color, with Castaña's Motruk line overplotted. Let's redo it without the Motruk line, and let's now look at the log plot. The log plot shows three tracks which correspond to the selected attributes, and in the fourth track we have the results of the petrophysical evaluation and the pay flag or target flag as black points in this axis. We can identify or verify the reservoir by making a line in the target points, in this case a blue line that maps to a blue point in the scatter plot, and a red line that maps to the red point in the scatter plot. So we verified that these low density points correspond to the reservoir. Let's now make scatter plots of petrophysical properties against attributes that can also be computed from seismic. Let's try porosity against mu rho, and let's leave the color coding by density. This is the scatter plot. Let's now do color coding by target point. The magenta points in here correspond to the target points. Let's color code by sand volume. And finally, let's color code by gas volume. Here we see that the reservoir corresponds to a clean sand, although it's not the cleanest sand in the interval being evaluated. We have cleaner sands in here with lower porosity. It is the reservoir has the highest gas content as expected and the lowest density. We also observe that the reservoir does not follow a linear trend. It looks more like an exponential function. So let's try to identify other attributes that can be used in this analysis. Let's do the relative properties, and let's do mu rho. We can see now that mu rho shows a more linear relationship, in this case with gas content. And let's now look at relative lambda rho. And this also shows more or less a linear relationship of the reservoir in the crossplot of porosity against relative lambda rho. So we're going to be working from here onwards with relative mu rho and relative lambda rho. Let's make a crossplot of these attributes, relative lambda rho against relative mu rho. And this is the scatter plot. Let's plot it again, keeping the x and y axis at the same scale. So let's do the axis from minus 1.5 to 1.5 in x and the same in y. So that is now the scatter plot. Let's take a look at the log plot. So that is the log plot. We have relative lambda rho in x, relative mu rho in y, and gas volume as the in the third track, or as the color in the scatter plot. Now we would like to get a single attribute that highlights or makes the reservoir stand out. So for that we're going to do an axis rotation of 135 degrees. What this does is that it's going to rotate the data with respect to the coordinates 135 degrees, trying to put all the points in the reservoir in the x-axis. Let's check the log plot, see how this looks in the log plot. And we see here that effectively most of the energy is now in the x-axis. The y-axis shows some energy, but it's minimized when compared to the attributes before the axis rotation, and this would be the gas percent. Keep in mind that this does not represent the gas volume or the gas percent. This shows the reservoir being highlighted, and the reservoir is a function of porosity, lithology, and fluids. And with this we conclude this clip, this presentation, and as I mentioned at the beginning of the clip, this is going to be complemented with the analysis at seismic resolution, in which we're going to make similar analysis with synthetic data. Thank you.